Hello students, so in this part we are going to study about two different types of analog modulation process. They are amplitude modulation and frequency modulation. In case of amplitude modulation, the amplitude of carrier wave is changed in accordance with an instantaneous value of the modulating signal. While in case of frequency modulation, the frequency of a carrier wave is changed in accordance with an modulating signal. So let's start with an amplitude modulation. Hello students, in this part we are going to study amplitude and frequency modulation. So let's start. First of all, let us start with the amplitude modulation. Amplitude modulation, in this, the amplitude of a carrier is changed in accordance with the instantaneous value of modulating signal. In the previous part we have seen there are three types of modulation: AM, FM and PM. Okay, and we also seen that when we change either amplitude, so it is amplitude modulation. If we change the frequency, it's a frequency modulation. If we change the phase, it becomes a phase modulation. Okay, so right now we are studying the amplitude modulation. So in this, the amplitude of a carrier, okay, whenever I am changing, we are changing the amplitude, changing the frequency, changing the phase. That means we are changing these parameters of a carrier wave. Okay, carrier is basically a high frequency signal. So in case of amplitude modulation, we are changing or varying the amplitude of the carrier, okay, in accordance with the instantaneous value of the modulating signal. So the amplitude is changed according with the instantaneous value of our modulating signal, that is the information signal. Okay, so we have so there are three important signals which we have to remember. One is the carrier signal. Another one is the modulating signal or information signal, and third one is the modulated signal, that is a signal after modulation. Okay, now carrier, okay, carrier signal, so it has amplitude Vc, frequency Fc, okay, and it's phi. Okay, phi is the phase. So now, so one more thing, that T is missing here. Okay, all these things T will come here, right? Yeah. Now, so whenever so in this we are having amplitude, frequency and phase. So but in case of amplitude modulation, we will be only changing the amplitude. If we talk about modulating signal, so it is having the amplitude of Vm and the frequency is Fm. Remember, I have already mentioned that the carrier frequency is much more greater than the modulating frequency, okay, or the frequency of information signal, right? The last one is the modulated signal. It is equals to Vc 1 plus mt cos 2 pi fct plus phi. How it comes? Since the modulated signal, okay, the signal after modulation will be of the form st equal to, so if we have the amplitude of carrier is Vc, so we are also adding our message signal, okay, mt, right, here mt, and then we'll multiply with the cos 2 pi fc and t plus phi. Okay, so basically if you see here in the carrier signal, so we are adding the modulating signal with the amplitude of the carrier wave, right? So we can see, depending upon the instantaneous value of a message signal, the amplitude of our carrier signal will change, and hence the modulated signal will have an information content in its amplitude. Okay, so the information is contained in the envelope. Envelope basically means the amplitude, right? Let's see this figure. This will give you more understanding about this amplitude modulation. It is also called in short as AM, amplitude modulation. So basically we have three signals, right? One is the information signal or a modulating signal. This is the carrier signal having a fixed frequency. Now you can imagine, you can clearly see here the frequency of carrier is much more, I mean it's a greater than as compared to the frequency of our modulating or information signal. So this is the AM signal, which or we can say the signal, modulated signal, which this will look in this way. So you can clearly see, okay, if you compare this carrier signal and the amplitude signal, so the frequency of both the signals is same, as well as the phase angle phi. Okay, this is same for both this, but you can see the amplitude is only changing. If you compare these two, only amplitude is changing. right? And amplitude is changing accordance with the information signals. You can see if the amplitude of information signal increases, the amplitude also increases for this. If it decreases, it also decreases, right? So it will follow the same. So information is contained in the envelope. This is called as an envelope. Okay, so this is called as an envelope. So our information is contained in the envelope of our resultant AM signal, right? So let us see, these are the important parameters which you have to remember. So our this VT is basically an modulated in the signal, right? So this VC is an amplitude of carrier wave. So I already explained that the your modulated signal will be equal to VC plus your message signal MT, okay, and cos of 2 pi FC into T. Now let's suppose if we consider the message signal MT as Vm cos of 2 pi FMT, right? So if you put this value here and if you take the VC common out, okay, so VC will be, so it will be 1 plus Vm, it will be Vm by VC into cos of 2 pi FMT, okay, multiplied by cos of 2 pi FCT, right? And this Vm by Vc, this is a very important parameter for amplitude modulation, okay, and it is called as an modulation index denoted by m, small m, okay. This is equals to the ratio of amplitude of modulating signal by the amplitude of, or we can say the peak value of your carrier signal, Vm by Vc. So this is a ratio, okay, and so therefore we can see this, the equation Vc 1 plus m is the modulation index, cos 2 pi FMT and cos 2 pi FCT, right? Here FC is carrier frequency, FM is modulating frequency, m is a modulation index, and also see this modulation index is lying, the value of modulation index m is between 0 and 1. That means we can say the Vm is less than Vc, okay, the value of Vm should be less than Vc so that the value of m will be less than 1, and both should be positive, right? If the value of m is greater than 1, then what will happen? Then in that case we say the overmodulation, and the result will be the distortion in the signal. There will be the distortion in the signal if the value of modulation index becomes greater than 1. We will see this in the next slide. So basically in this slide I have tried to explain what the effect of modulation index, varying the modulation index. If we vary the value of modulation index, then how the waveform of AM gets changed. First of all, you see the first signal. This is a signal of a modulating signal, that is the information signal. The second waveform is of an unmodulated carrier signal. So this is our carrier signal having higher frequency as compared to the information signal. Third signal is an modulated signal, okay, modulated by a modulation index of 0.5. So in this case the modulation index is, the value of m is 0.5, okay. If we see the fourth signal, in case of fourth signal, the modulation index, the value of modulation index, that is m, is equals to 1, right? So you can see here, if you see the envelope go in this way, right? So they are separated, you can see that there is a distance, but if we choose a value of m equal to 1, so this envelope, okay, this upper and the lower envelope touches each other, okay, so this distance becomes 0, right? Now even if we increase the value of m greater than 1, that is the case of overmodulation. In that case what happen? Our signal information get lost, okay, and the carrier is turned off for this region, because in this case actually the happen is the envelope goes in this way, right? So there is a cross phase modulation. I mean this phases gets overlap and this information gets distorted. I mean there is a loss of an information due to increase in the value of modulation index. So whenever the modulation index becomes greater than 1, so there will be a loss of an information, that is called as an overmodulation. Let's see how the frequency spectrum of AM wave looks like. Okay, so as we have seen the signal or the equation, okay, in the equation form, how the equation of an amplitude modulation signal look like. So it is equals to Vc 1 plus m into cos of 2 pi fm t into cos of 2 pi fc into t. Okay, so when you multiply this, we will get as Vc cos 2 pi fc t plus m into cos 2 pi fm t multiplied by cos of 2 pi fct, right? So first of all, if we see this Vc cos 2 pi fct, so this will have a, see, this is a single frequency component, okay, that's cosine wave. So this we will have a amplitude, so Vc you can change it here as Vm and Am. So you can see, so we will have a one frequency, okay, that is at the frequency fc. Okay, so there will be one peak at frequency of fc. Okay, and if you see the second term, that is the multiplication of cos 2 pi fmt and the cos 2 pi fct, if you multiply by 2 and divide by 2 and you apply the formula of 2 cos a to cos a cos b, okay, so we know that there we get two terms. One is cos of a plus b and the second term we get is cos of a minus b. Okay, that means here we will get the two frequencies. One will be fc minus fm and one will be fc plus fm. So we will be having two components. Okay, one will be at fc plus fm and another one will be at the fc plus fm. So we can see we are having, so actually we were having the modulation, our modulating signal of frequency fm, right, and the carrier signal of frequency fc. After modulation, what effect we are changing, what we are seeing in the spectrum is we are getting two additional component, one at fc plus fm, which is called as an upper sideband, and another at the fc minus fm, this is called as a lower sideband, right? So these two components, frequency components, which this we got, right? So basically this will be the frequency band for an AM wave, lower sideband, upper sideband, and the carrier frequency. So we can easily determine the bandwidth. The bandwidth will be the range of frequencies, right, in which our signal lies. So it will be basically the difference of upper sideband and the lower sideband. Upper sideband is fc plus fm, lower sideband is fc minus fm. Therefore, the bandwidth will be twice of fm. So we can say that the bandwidth of an AM signal is twice the frequency of the modulating signal, right? So now let's continue. Frequency modulation. Right, so amplitude modulation is completed. Now let's see frequency modulation. Since this topic is not much more in our syllabus for the 12th standard, therefore only this one slide I have given just to give you the information like what is frequency modulation. Okay, so frequency modulation. So like we have seen the case of amplitude modulation. In case of amplitude modulation, the amplitude of carrier wave is changed in accordance with the instantaneous value of the modulating signal. Okay, so same in case of frequency modulation, the frequency of carrier wave will be changed in accordance with the modulating signal. Okay, so if you see the definition, so in case of frequency modulation, the encoding of information in the carrier wave by varying the instantaneous frequency of the wave. If we we can clearly see from this diagram. Let's suppose this is our modulating signal and this is the carrier signal. Okay, and the carrier frequency is much more greater than the modulating signal. Now if you, this is the basically our FM signal, FM modulated signal, FM basically frequency modulated signal. So if you compare these two signals, so the amplitude of both this, the amplitude of both of this is same as well as the phase is same, but you can see the frequency is not same, and the frequency is changing depending upon the amplitude of the modulating signal. The frequency of an frequency modulated signal will change accordance with the amplitude of the modulating signal. You can see the frequency was fixed in case of carrier frequency, but in carrier signal. But if you see the FM signal, the frequency increases when the amplitude increases, and the frequency decreases when the amplitude decreases. Okay, so we can see that the frequency, so our information is contained in the frequency, okay, of an FM signal. So in this way our signal looks like for the case of FM modulation. Okay, now let's solve example that will give more understanding. So a message signal of frequency 10 kilohertz. So we are given message signal of a frequency 10 kilohertz, that is the value of FM is 10 kilohertz, and the peak voltage of 10 volts, that is the amplitude voltage of, that is VM, is 10 volt. So this is used to modulate a carrier of frequency 1 megahertz and peak voltage of 20 volts. So this message signal is used to modulate a carrier signal having the frequency FC equal to 1 megahertz and the peak voltage, that is VC, equal to 20 volts. Okay, so determine the modulation index and the sideband produced. So right now we have seen the modulation index denoted by M is the ratio of VM by VC, and we are given the value of VM is 10 volt and VC is 20 volt, so it comes out to be 1 by 2 or it comes out to be equal to 0.5 volt. And the second is to find the sideband, and we know that the sideband is basically there are two sidebands, upper sideband and the lower sideband, right? So upper sideband is equals to FC plus FM and the lower sideband is FC minus FM, right? The FC is given to us as 1 megahertz, or we can consider it as a 1000 kilohertz, and FM is 10 kilohertz, right? So this will becomes 1010 kilohertz. And if we find out the lower sideband, it is FC minus FM, that is 1000 kilohertz minus 10 kilohertz, right? So it will be even 990 kilohertz. Okay, so this is the answer for these questions. Let's move on to the next question now. So next question is, a carrier is simultaneously modulated by two sine waves having the modulation indices of 0.4 and 0.3. The total modulation index will be. In this case, what we are given that there are two modulating signals which are modulated, right? And one of them is having the modulation index, that is M1 is equals to 0.4, and the modulation index for the another signal is 0.3. So what will be the resultant modulation index for the final AM signal? So the relation, final modulation index will be equal to under root of M1 square plus M2 square. This is the relation we can find out. So even if we have n number of sine waves, so we can add up all this in the similar way, right? So right now we are having only two sine waves, so only we are writing M1 square plus M2 square. So to find the value of M, it will be under root of 0.4 square plus 0.3 square. So this will be like 1 by 10 of under root of 4 square plus 3 square, that is 16 plus 9. So it will be 1 by 10 of under root of 25, which will be equal to 5 by 10, and this will be equal to 0.5. Therefore the answer for this question is option C. Hello students, so in this part we have studied about amplitude and frequency modulation. In case of amplitude modulation, we have seen the different waveforms of modulated and the carrier signal. We have also seen the effect of modulation index on an amplitude modulated waveform. In the next part, we are going to solve some previous year IIT-JEE question. So stay tuned with us.